I saw this joke on Twitter and it's a good introduction for this video. It is a joke because on the left-hand side we have a thought process for differentiation. It's pretty straightforward. We can look at a function and decide whether to use the chain rule if it is a composite function, the product rule if we have a product of two functions, or the quotient rule if we are dividing. And that's it. It's pretty straightforward. Integration, however, on the right-hand side here, as you've seen in our lessons, there is a huge number of different things that we can try. Some of them work in some cases, some of them work in other cases, and it is very, very difficult to find the right technique sometimes. So, this video will hopefully help you to choose the right technique, save yourself some time. This is the thought process that you're going to go through, and I'm going to take you through this. You should hopefully already have this printed out in front of you. So, first thing to say is, when you see an integration question, stop and think. Do not immediately start working on it. So often I find students will spend a good 10 or 15 minutes going through integration by parts or integration by substitution, and they'll do a whole page of working out for a 1 mark, 2 mark question that they could solve really quickly if they just stopped and thought about it and tried some simpler techniques. So, when you see an integration question, stop and think. And think about these things. First thing to think about, can the expression that you are trying to integrate be rewritten? For example, if you have brackets, in this case here, I could just really simply expand those brackets to get t cubed minus t squared, and then each of those terms integrates really nicely and easily. Do we have index laws? So for example, in this case here, I've got 1 over x plus 1 squared, and I could rewrite that as x plus 1 to the power minus 2, which then again integrates really easily. Is there a division? Can we rewrite this division in an easier way? And yes, I can, because I'm just dividing by one term on the denominator there. I'm just dividing by x. So I could rewrite that really easily to be, well, x divided by x is 1. And then the 1 divided by x is 1 over x. And then each of those terms integrates really simply. So first thing to think about when you are doing integration is, can you rewrite the integral in an easier way? Next thing to think about, specifically if you have trigonometry, can you use an identity to rewrite the integral in a simpler form? For example, we know that we can rewrite cos squared with the cos double angle formula. So just rearranging the cos double angle formula gives that cos squared is equal to a half cos 2x plus 1. And then that, each of those terms, the cos 2x and the 1 can be integrated separately really easily. You can do a similar technique for integrating sine squared as well. Or if you have a product of sine and cos together, we know that we can rewrite that with the sine double angle formula, which again makes that really easy to integrate. If you have a squared identity, in this case tan squared, I know I can rewrite tan squared as sec squared minus 1. And then the sec squared I know integrates to be tan, and the 1 integrates to be x. So that now integrates really easily. So if you have a trigonometric expression, check on your formula sheet to see if you know what the integral is already. If you do, great. If you don't, can you use an identity to rewrite the integral in a simpler form that you do know? Next, remember the reverse chain rule. Something might look complicated to integrate, but do you have a linear function inside another function? If you do, all you need to do is integrate the outside function the way you usually would, whatever that function is, leave the inside the same, and then just divide by the a. So you can see in this example here, the outside function is 1 over, and I know I can integrate 1 over with an ln. So I can integrate the 1 over function to be ln 1 minus 2x. And then I just have to remember to divide by minus 2. That's the a in this case, minus 2. So dividing by minus 2, that's where the minus 1/2 comes from at the front. So that's the reverse chain rule. Next thing to think about is these special types of integral where we are spotting a derivative. These, if you can spot them, will save you a huge amount of time. If you can spot a derivative, then you can just integrate the other function the way it normally would do, and you can ignore the derivative completely. So, for example, there was 3 types we saw. In this case here, I've got my function on the bottom, and I've got the derivative of that function on the top. In that case, I can ignore the derivative completely and just integrate the function the way I normally would. So the 1 over f of x would integrate to be ln f of x. In the next example, I've got a function inside a power that's being multiplied by its derivative. Again, I would ignore the derivative completely and integrate the power function the way I normally would. And when I integrate a power function, I add 1 to the power and divide by the new power, with the function being on the inside. And the third special type of integral to spot, if you have the derivative of the function that's inside the exponential, again, you can ignore the derivative completely and then integrate the exponential the way we normally integrate the exponential. The exponential integrates to be the exponential with the function on the inside. So if you can spot those special types, that will save you a huge amount of time. So that's the 4th thing to think about. Next, we get to the integration by parts. We do integration by parts when we have a product of 2 functions. So in this case, in this example here, I've got the 1 over x squared multiplied by the ln x. It is a product of 2 functions. So I'm using integration by parts. The integration by parts formula is given to you in the formula booklet, but it is basically uv minus the integral of u dash v. You will choose the u function to be ln if you have an ln. Otherwise, if you don't have an ln, you will choose your u function to be a polynomial, a function in x. Once you've done that though, once you've made your choice, you will differentiate the u function, you will integrate the v dash function, and then apply the formula. So we're using integration by parts if you have a product of 2 functions to be integrated. Next, if all of those things that we've thought about so far, if all of those things haven't worked, then I would then start to think about integration by substitution. The key thing to think about with integration by substitution is you are always differentiating first. It doesn't matter what I'm integrating it is the dx that I need to replace first. That's the key. So you are always going to be differentiating either to find du by dx or dx by du. You want to differentiate first, then rearrange to make dx the subject so that you can swap the dx. That's the most important thing about integration by substitution. Other things to think about. If you have a rational function, so one function over another function, if you have a division, well, we can use partial fractions. For example, in this case here, I could rewrite my 2x over plus 1 over x plus 1 times x plus 3. I could rewrite that as in this form, work out my a and b, and then integrate each of those separately with a logarithm. Or, in this case here, I have an improper fraction. The order on the top is 1, the order on the bottom is 1. It is improper, so I could do some division first. That way, I can rewrite it in a form where I will have 2 plus the remainder over x minus 1, and then that makes it easier to integrate. And finally, if you have parametric curves, so if you have x as a function of t and y as a different function of t, then to work out the area underneath that curve, you are going to differentiate your x function. You're then going to multiply that by your y function, and then whatever you get, you integrate that with respect to t. And just remember that the limits have to be in terms of t as well. So there we go. That is your thought process for what integration technique to use when. Remember, when you see an integration question, stop, think, can it be rewritten in a simple way? Is there a trigonometric identity that you can simplify your integral so that you can use the formula sheet? Do you have a function on the inside? Do you need to divide by a? Is it a special type? Can you spot a derivative? Is it a product? Can you use integration by parts? Do you need to use a substitution? Do you have a division? Do you have a fraction? Can you split it up using partial fractions or some algebraic division? Or do you need to use parametric integration?